opportunities to reduce the heat signature. A lot of new technologies that the engine companies are looking for include seeking the best ways to ensure maximum performance of the engine while using an IR suppressor, Tobin explained. A key strategy, Tobin explained, is to use IR suppressor to reduce the signature so that less jamming is needed to confuse enemy radar. Bell intends to build upon and advance existing tiltrotor technology such as that which is currently in operation in the Bell Boeing V-22 Osprey aircraft. The Osprey continues to perform well in a wide range of missions and has recently been selected by the Navy to perform the Carrier On-Board Delivery or COD mission, transporting troops, equipment and weapons on and off surface ships. The V-280 Valor is designed to be slightly bigger than an existing Black Hawk helicopter and use 24-inch seats to carry 11 passengers with gear, Tobin said. Bell is taking its historical V-22 aircraft and applying them to this next-generation tiltrotor, yet it uses a straight wing versus a V-22 which is not straight, Army developers said. Bell is also building additional flapping into the rotor system and individual controls that should allow for increased low-speed maneuverability, Army and Bell developers added. The tiltrotors were engineered into the aircraft last year, Tobin added. We will get the gearboxes and transmission in before we get those blades on, Tobin explained. Depending upon ultimate requirement established by the Army and DoD, Bell expects to engineer an attack variant of the aircraft with a slightly different fuselage configuration. An armed attack version will have a gun, 2.75 and folding fin rockets and some type of point-to-point missile, Hellfire or some later generation missile that would guide off of a laser or IR. We are being open-ended in that we are not designing any specific requirement, Tobin explained. The V-280 Valor next-generation tiltrotor aircraft for the 2030s includes the integration of a high-tech 360-degree sensor suite quite similar to the one used on the F-35 Joint Strike Fighter called a Distributed Aperture Systems, or DAS, developers explained. Instead of having sensors mounted to the turret, you have sensors that are mounted to the aircraft, so essentially you have sensors staring in 360 degrees around the aircraft at any given time. Those images are stitched together so it appears as one continuous image to the pilot. Both pilots can make use of the same system, Tobin said. This technology will also allow troops riding in the back of the aircraft to wear goggles or a helmet giving them a view of the surrounding sensor feeds as they transit to a mission, Tobin added. The Northrop Grumman-built DAS system will also form the basis of a small arms enemy fire detection technology which will search for and locate the signature of incoming enemy attacks. The sensors will be able to discern the location and heat signature coming from enemy small arms fire, giving the aircraft an opportunity to quickly attack with its weapons, lowering risk of injury to the pilots, crew and passengers. The new Bell tiltrotor, called the V-280 Valor, is part of the Army's Joint Multi-Role Technology Demonstrator program aimed at establishing requirements and paving the way toward a new future vertical lift aircraft designed to meet a wide range of new requirements. The concept behind the Army's Joint Future Vertical Lift program is to engineer a forward-looking, future aircraft able to reach airplane speeds and yet retain an ability to hover and maneuver like a helicopter. The aircraft will have an ability to come to a hover in challenging conditions and then, while at a hover, operate at low speeds with maneuvering capability to roll and yaw. We wanted to have the handling perspective to make the aircraft able to do what it is able to do, Tobin added. The V-280 Valor will also have yet to be determined a graded visual environment technology that allows sensors to see through obscurance such as brownout conditions, bad weather and other impediments to navigation. Part of this will also include a system called controlled flight into terrain wherein an aircraft has an ability to quickly reroute itself it is approaching a dangerous obstacle such as a mountain, rock wall or building structure. The new attack variant is expected to use a modernized or next generation of existing Apache sensors and targeting systems called the Modernized Target Acquisition Designation Sight/Pilot Night Vision Sensor, or MTADS PVS. When it comes to sensors and mission equipment, Bell engineers are building a tiltrotor aircraft with what is called open architecture, meaning software and hardware able to quickly integrate new technologies as they emerge. The concept is to construct a helicopter that is not intended to operate today but rather advance technology well into the 2030s and beyond. Therefore, it will need to anticipate the weapons, sensors, computer processors and avionics likely to emerge by the 2030s. This will likely draw upon a semi-autonomous navigation technology built into the aircraft known as fly-by-wire. Bell Helicopter developed the initial algorithms for this technology, which is also now on the V-22 Osprey. Another survivability technology potentially slated for the aircraft is a system known as Common Infrared Countermeasure, or CIRCM. CIRCM is a lighter-weight variant of an existing technology which uses a laser jammer to throw incoming enemy missiles off course, therefore protecting the aircraft. We are looking to the DoD customer to see what they want. Either way we can get that on the airplane, Tobin explained. Bell Helicopter has now attached the wing to the fuselage of the new tiltrotor aircraft engineered to reach speeds of 280 knots, fly for 800 kilometers on one tank of fuel, hover and maneuver in high-hot conditions and function as both a utility and attack helicopter platform. The intention is to build an advanced, high-tech tiltrotor demonstrator